All right, here is the speed run of Ben, Ben, or Ben, the fourth case from the Benevolent tournament here in August 2026. We're going to start with the built-in mid function, right? So just, mid of that, length 1. Next, I'm going to use count substring lambda, maybe my most used lambda. It's already case insensitive by default, which is what I want for this. Um, for this, I'm going to need to process this data table. I will just make this a data table, call it D, maybe even get rid of the banded rows. Um, so now I'm going to split this up and I'm going to make it lowercase, right? Had some mistakes in this case because of case sensitivity. We want everything to be case insensitive. All right, so text before this, before the space, lowercase, and then the text after. Um, and now I'm going to filter the order, right, which is the row, by D first name equals the given first name, and then the same thing for the last name equals the given last name, right? And now I want the set union of these, right? Add them together, get rid of the duplicates, and then I need, the rows of this. If they were missing, I'd have to handle that, but none of them are missing, so I don't have to. This here's kind of different, right? This here I need the full name, right? So why don't we do first name and a space and the last name and call that name. So now count substring of D name. The substring is there, right? So we'll do that for every one. And I'll do the sign just in case there's more than one. So I just want to turn it into a sign. I'll just turn it into a 1 or 0. And now I XLOOKUP 1 on here, returning on D full name is the answer to this, right? Which is part of why I need to make the full name, is because that's the answer to this. Now here, I got to split again, right? But this time I'm splitting based on a comma. So I got to change my delimiter, right? This is name 1 and name 2. I'm going to quickly make a lambda out here to find all the substrings, so I don't have to do this twice. So if this is the name, then the length of this is here. So then all the possibilities, this is my cycles lambda, just counts, don't hard code that. If you hard code that, the whole thing's gonna go crazy, right? I don't know why it wants to make that an old formula. There you go. All right, so that's the cycles, and I gotta split this into the 2 rows so I can map it properly. So the first column of that and the second column of that lined up. And this is overkill, but it doesn't hurt anything. So this is the way I do it, because not all of these are even possible. But I'm going to map on both of those, lambda A, B, the mid of the name, AB, right? A, starting at A, going B. And like a lot, this is always going to be the same, but it's fine, don't hurt anything. Because at the end, I'm going to use my set lambda, which unique and sorts it. And this is all subs here. So given, oh, and I gotta make this so it doesn't go back any farther using, so this is OA Robot. See the link in the description for more about OA Robot. And all subs save lambda as, right? So this takes a name and gives me all the substrings that can be made from it. Is there, all subs. So now I need all subs 1, all subs 2. I need to know the common subs, right? And then I need to know the numerator and the denominator. So all subs of the first name, all subs of the second name, right? The common ones, that is a set intersection, right? So I only want the ones that are in both of these. This matches what it says in the example, right? And the numerator is the max of the length of these, and denominator is the max of the length of this and the length of this, right? And these are the, well, I'll make the lambda later. And then I'll just do some similarity, right? Is 100 times, in parentheses, this over that. And then the answer is the similarity rounded to 0 decimal places. Now here, I got to do something a little different, right? Because I'm doing the substitutes, right? Which are here. So I do the substitutes, but I got to do them forward and backward. So I'm going to double this table, just bringing, just switching this over. Right? And I got to do this row-wise, right? So now so name in, I'm going to make sure to remember to lower it because substitute is case sensitive, which is why I did not do so great on this case. Name in is there. So now the subbed version is map of this lambda or this array and this array, lambda A, B. And then, right, it's the substitute built-in function starting with that. The old text is is A, and the new text is B, and those are the possibilities. I want to get rid of the duplicates again, right? So I use my set lambda. You could also use built-in unique. That just sorts it, which is irrelevant in this case. And then now I got to count them, right? So how many times do these appear? Count should broadcast fine without me having, countf will broadcast without me having to map it. The range that I'm checking on is D first name. And then the criteria is each of these. So add these up. And that's the answer to this one. So now for here, I got to basically apply that same thing, but to two names, right? So what I need to do is make a lambda, but not all the way to here. The lambda's just to here, right? It's just the numerator that matters because I've got to apply a penalty to the substituted numerators before calculating it. All right, so this, I'm going to do this. I'm going to call it, not going to call it the numerator, but I'm going to call it the common subs, the, longest common sub. So the longest common sub is there based on name A and B, right? So longest common sub based on A and B is part of this, right? It's 3, that we know, but we also have to do the substitutes. So and that's not it. Substitutes are based on this, right? So just gonna grab these like this. So now, except I do need this whole thing because this is hard coded. So now with the first name, that's there. Name number 1, and then I'm going to do the same thing. I don't need name in because I've already applied the lower to it. So I'm going to do there, and I'm going to do there, right? So those are this, and I got to do this row-wise, right? You're not checking every possibility. You're going by row here. That's also something I did wrong on the thing. Because it's got to be this. It's got to be what's in common with this one. You can't do an IE on one of them and a K on the other one. That's not allowed. All right. So now I need the least common substring for all of these, right? So the map of here and here, lambda A, B of the longest, not the longest, not the least, but the longest common substring of A and B, right, is this. So the numerator now is the max of this is a possibility. The other possibility is the max of this minus 1.5, because if you have to do a substitution, you take away a 1.5 penalty. The denominator then is same as before, the max of the length of these. So the similarity is 100 times this over that. And then round this to 0 places. Hopefully that will get us 1,000 points so far. Let's see. Ta-da, 1,000 points so far. So what's the longest name in the data set? My biggest lambda can do that. I'm checking the length of the first name. Hint, it's not Ben. No, it's not Ben. That's the length, and then the returning is on the first name itself, because that's the answer. Most common last name, again, is a lambda, right? So frequency table of the last name, the at just pulls out the most common one. The last name, like that. People who have the exact same name, right? So let's just do, count. So COUNTIF, the, the name matches the name, right? But not one of them without the thing there. Other way around. And then look at the ones that are doubled. There are indeed 4 of them. Biggest strictness is 94. That's the only place we're using strictness, apparently. What letter of the alphabet is used the most often? This I got wrong because of case sensitivity. So frequency table of the lowercase of the name is there of string to array of the name. Other way around. So first do, so equals string to array of the name, first of all, is all that stuff, which is good. And lowercase it all, right? And now give me the frequency table of all that stuff. A is the most common letter. So now, is there no A? Well, if count substring of it's already right here, of the name A, and it's case sensitive already. If that is 0, then 1, otherwise 0. Sum these up, 287. How many people's matches this regex here? I got to pull out it's just the first name, I assume is what he meant. I know it's right because I got points for it on the case. So it is the sum of negative regex test the first name with the pattern being right there, close, and that's it for Ben, and Ben. Thanks for watching. Bye.